Okay, so let's move on the next part of our session. So our next speaker is Arun Natarajan. He is working as a principal consultant in Emirates NBD. So he has the 15 years of experience. He is a IT solution architect, and then he is specialized in cloud native computing and then automation and DevOps related applications also. So he is going to talk about 12 factors of cloud native application development. Okay. So, yeah, Arun, you can start.
Uh, Thanks, Vera. Okay. Hello, everyone. Good morning. I think I'm just following after a very good session handled by my friend INR. And thanks for the CNCF Madurai team for organizing this event. So I'm going to take you through the this 12 factors app. So what is this all about, and why we need to implement it in our enterprise level organization. Okay, I'm just sharing my screen. Okay, okay. Are you guys able to see my screen?
Yes, Arun, we can
Yeah,
see.
yes.
Okay. So in this session, I'm going to walk you through this 12-factor app. This 12-factor app is essential for any organization that is in the bigger level when they are delivering any software product to the customers. So this is the way which needs to be followed for the betterment of the environment in terms of cost, in terms of maintenance, in terms of the stability and all those stuffs. So this is in turn is a methodology. If we follow it, and our environment will be strong, stable, and also the resilient. So we are going to discuss all these 12 factors. Using these 12 factors, how we can able to create this microservices or the containers. So once I done with the sixth one, we will have a break and we can have a discussion, and then we can have the discussion at the end of the session. And if you have any questions in between, please feel free to post it in the chat. So let me get started now. So starting with the first with the code base. So what is the code base which we need to follow? See, when we are developing a particular software products, initially a developer will be developing a code. So when it comes to the enterprise level, it is not one person who will be developing the code. It will be the multiple person who will be developing it. So when there is a contribution from several people, how we will consolidate all the work together and how we will get streamlined to make that into the production. So for that, what we need to do is we need to use any of the version control system which is available in the market, and then we can able to consolidate the code. So that is the one of the example which I am listing here is the Git. So here in the market we have GitHub, Bitbucket, and Apache SVN, like so on. We are having multiple version control system in the market, and we need to use any one of those so that we can get the work done from everyone, and accordingly we can able to commit the code into our respective branch and we can deploy it into our production system. So this is the first example for the code base where we need to use any version control system while developing a software product. And the second one here is when we are developing an application, that particular application will be consist of a multiple service. Let's say on a banking system, the particular banking application will be having the search service, payment service, credit card service, debit card service, invoice service, like that. And when we are having multiple services, if we are storing the if the code in a single repository, and if you are deploying it in the various environment for our testing purpose, this can be a bad practice. So why this is a bad practice? Now let's say if I want to make any changes for my search service, if I'm deploying it, so at that time all the three services will be deployed instead of one. So it is not a good habit to have a single repository for the multiple products. So this is not the advisable. So what we need to do is, for each and every product, we need to have a separate repository, and from the separate repository, once the code is built, we can able to deploy it in the respective environment, and we can test it accordingly. So if I want to make some update to the search service, I can do the changes, and I can do the testing in the dev and UAT, and then I can deploy it in the production environment, so that payment service and invoice services will not get affected. So this is something like a independent. So here we need to maintain a separate repository for each and every product. So what CNCF says is, it says multiple app sharing the same code base is a 12-factor app violation. So for each and every service, we need to have a separate repository. So this is all about the code base. Now let's move on to the second one, dependencies. So what is the dependency? See, when we are developing any text stack code, it can be a Java, Python, React, Node.js, or whatever it is, we will be having some jar file or war file to deploy it into our repository. Okay, when we are deploying this code into the repository, we will be having also the dependency files. It can be a pom.package.json or gradle file, something like that, which we will be pulling it from the maven repository. So in the code, we will be having the business logic. In the dependency, we will be having all the library, binary, all the supporting files. So this should be separated. Why this should be separated? Say for an example, in the traditional method, people will install the tools in their machine, so the code will work for one person and it will not work for the another person. So instead of that, we need to separate it, and so that it will be pulled from the respective environment, and accordingly they can build the code. So they will be building with their respective image, so that the container will be ready and they can deploy it into the respective environment. So this is how we need to keep the dependencies isolated. So what it says is, finally explicitly declare and isolate the dependencies. So dependencies should not be a part of a code. So this is what we need to maintain for the dependencies. So we are done with the second one. Moving on to the third one, the configurations. So when we are developing any microservices or containers, we will be having the application code. Okay, with the application code, we will be also having the configurations. Configurations in the sense like what is the DB name, what is the Redis cache, what is the SSO. For the authentication which is getting connected, and all those things. So all those configuration should not be a part of a code. So let's say this is the Java code snippet which you guys can able to see here, and you can able to see here the Java, this JDBC, this one Java database connection. Here I have mentioned here also mentioned with the username and the password. This is hard coding the data. So this should not be a practice. So we should not hard code the data into our actual code. This is a bad practice. And what we supposed to do is, the application code should be separated from the configuration. Okay, we should separate the application code and the configuration, like an example. So we should maintain a separate file for all the configuration details what we have. It can be a database host, a port number, username, password. It can be a key, a secret, or whatever the variables which we are declaring. And this is the code. So here in the code, it will be calling it from the respective configuration file. So when it comes to the DB username, it will call from the this configuration file. So respectively, all the variables will be called from here, and where we are not hard coding the values in the actual code. So this is the practice which we need to follow. This is the one example for the config. Let me move on to the another example. So when we are having a code, we should maintain a separate environmental file for each and every environment, so that, see, even sometimes the database name will be differing from one environment to the another environment. So accordingly, we can input those information in that file for that respective environment, and we can bundle it with the respective image what we are using it, and finally we can deploy it to our respective environment. This is how we need to maintain the configuration. So the code only will be in the Docker image, and the configurations, that is the environment configuration, should be in the environmental file. So finally, store the configurations in the environmental file and not into your code file. So now we are done with the third one. We are moving on to the fourth one, backing service. So what are the backing services which we need to uh, have it? Now, say for an example, when we have an application with us, for sure, each and every application on the enterprise level will be supported by the many other backing services like Kafka, for the MQ messaging and the broker services, and also databases to store the data, and also Redis for the DB cache management. Like this, we will be having multiple uh, supporting or the backing services. And apart from that, this SSO authentication, token generation, like so on, we will be having it. Now we need to have these services as a attachable detachable service. Just by mentioning the URL, the application should be able to access the database. In such a way, we need to architect our application. Now if this database goes down, what happens? Now immediately we can able to, just by changing the address, we can provision the another database, so that the application will run without any interruption. So this is what we need to make it as a plug and play option. So when some attached resource goes down, we need to just provision it just by changing the address. So in this way, we need to make the backing services in the plug and play mode. In such a way, we need to do the architecture when we are developing a particular product. So treat the backing services as attached resource. So this is the case for the backing services. So now we are done with this. Moving on to the fifth one, that is the build, release, run. This is an important stage which we need to know it and understand it thoroughly. So when we are developing an application, we need to make the different stages. That is a build, release, run, and it should not be on the single stage. It should be in the different stages. Now, what we need to do here is we need to make that into the different stages. That is, build should be in a different, release should be in different, and run should be in the different. So what we will be doing in this different stages? In the build stage, we will be building the code. That is, the code will be combined with the images, and finally we will be the build will be ready. That is, the code will be in one repository, and the image what we are using to develop a container, that will be in a different repository. The image for building up the container, so we will be having the two repository. So this Docker images will be in any of the Nexus repository or the JFrog, something like that, so that we can able to make the build ready. Once the build is ready, we can able to release it. What this different types of different versions of release? See, in each and every version we might have a different versions of our code. Let's say in release 1 we will be having Java 1.8, and release 1.1 we will be having Java 1.1, and so on. So if any of the version is not working, then we can roll back to the particular version, and we can make our code running on. And once it is really respective release version is released, we can deploy it in the run stage to the respective environment. So for this reason, we need to maintain the different stages: build, release, run. And in the run, we will be deploying the actual code. See, the main reason why we are splitting into the different stages is during our deployment, starting from the building and the deployment, if there are any issues, we can easily navigate into it, and easily we can mitigate the issue easily by getting onto the respective stage, by identifying the issue and fixing the same. And that's why we are splitting into different stages, and this is what is recommended. And this is the way which can be splitted into which is CA and which is CD. CA part comes into the integration, that is which we are building the code when the code is getting ready and it is getting ready for the release with the different version. And the CD comes into the picture, how we are deploying it. See, in the actual market for CA, we are having multiple tools to do the CA/CD operation. For the CI, we are having in the market like Jenkins, Bamboo, or even with the Ansible, which we can do it. For the CD, we have again with the Ansible, Terraform, Argo CD, like so on. So we can able to choose the respective tools for the CI and the CD. So this is what we need to do the with the different stages. And finally, it says as strictly separate the build, release, and the run stages. So now we are done with the fifth factor, and now we are moving on to the sixth factor, processes. So what is this sixth one? The processes. When our end users are accessing our application, for sure it will be available through the load balancer. Whereas the end user does not know whether it is behind the load balancer or not. But as a developers, if we would know it is behind the load balancer, and behind the load balancer there will be multiple instances will be running it. So that is a microservices 1, 2, 3, 4, and it goes on. So when the user is accessing the application, the request will be processed in any of the microservices. And during that time, the client information will be stored in the microservices, right, which will be processed. Their information will be processed in the microservices. At that time, the information should not be stored in the microservices, and it should be stored only in the supporting resources, that is a database or the redis cache. Now the reason why we are not supposed to store those user information into the microservices is, so now this microservices may go for a reboot or may go for a shutdown, or it may get any issues. So if we are storing the session info or the user info into this microservices, and if this goes down when the request is being processed from the another container, and then it will make some issues. So that's why all the data or the information, session details, the transaction ID, URC code, all those should be saved in the database and not on the microservices. This is the reason. And if we are storing the data into this same microservices, and that will lead to the called as a sticky session. And sticky session should be entirely should be avoided, and that's why I have made it in the red. So storing making a sticky session, the application will not work as expected, and which is also not recommendable by the 12 factor app methodology. And this is the processes which we are saying it. And what it says is, finally execute the app as one or more stateless process. Stateless process means, so that is don't make the memory into the containers, so don't save it anything locally into the container. And this is what the process says. And we are done with the first six factors. If you guys have any question, you can ask me before I proceed. Else, we can proceed with the seventh factor. Any doubts on the first six factors?
Arun, I have one doubt regarding the config file. So,
Yeah.
where do we need to place the .env file? Whether it is in the repository or
Repository, yeah, in the repository, yeah, in the repository. See, in the repository, while we are building it, in the repository, while we are building it, so this Docker image will be getting it from the Nexus repository, and this env file will be getting it from the GitHub repository, and we can able to merge the both, and we can able to make the image ready. So maybe in the further session I can also give you a demo on this. I hope this is Selvi, if I'm not
yeah, yeah,
wrong.
yeah, yeah,
Okay.
Selvi, yeah,
Okay, right. I'm not able to see the names or anything. Okay, sure,
yeah,
Selvi. I will give you a demo, push this session for you.
yeah. Okay, thank you, Arun.
Okay. Okay. So moving on to the seventh factor. Okay, port binding. See, in the traditional method, what we were doing for deploying the particular code, when a developer is get ready with their code, either it can be a jar or a war file. So as a production support engineers or the application support engineers, where we used to deploy it in the particular instances, Tomcat server 1, Tomcat server 2, Tomcat server 3, which we will be deploying it, and then we will be restarting the Apache web services. This is, we will be restarting the HTTPD, and also manually we will open this 8080 port number to expose that particular service. So this is what was happening in the traditional method, where we will be deploying the code in each and every instances, and then we will be restarting, and then we will be opening this particular port number. But what we will do in the 12 factor app method is, once the software products are built as a containers, we will be exporting the service as a port binding. That is, we will be having our code, that is as a war file, and we will be deploying that with the image. So in the docker we will be writing the instruction in the docker file as a expose 8080. So these instructions will be given in the docker file. Accordingly, that application will be get exposed from the docker file instructions, and that's how we will be exposing the service. Once the image is ready, then we will be deploying it as many as times which we need, depend on the number of containers. So now we are deploying it for the 4 times, that is, it is generating as a 4 containers into a single server. In the previous traditional method, which we were deploying in the different servers, and here we are deploying in a single server by exposing the service from the Docker file. So this is what which we need to know from the port binding. And finally, what it says is export services via the port binding and not on the server level. So now we are done with the seventh one. Moving on to the eighth one, concurrency. What is this concurrency? The word indicates running multiple process at the same time. It's a concurrency. So when we are having the vertical scaling. So what is this vertical scaling? See, in the server, when the server is not able to handle enough traffic, we will be increasing the server capacity in a single server. Please make a note that in a single server, if we are increasing the capacity, that is called as the vertical scaling according to the load which is getting increased. So if you are in a single server, if you are having 1 GB of hard disk and 1 TB of RAM, and if you are increasing the memory on the same server, okay, for the when the load is increased, and when the load is decreased, we cannot again remove it back. So it involves a lot of maintenance, a lot of budget on all those stuffs. So this is a wrong practice to have a vertical scaling methodology in our environment, which is not recommended. So what we need to do is we need to use the horizontal scaling. Whenever the load is increasing, we need to add the few more instances or few more pods to that particular application. If the single instances is having a one 1 GB of a storage and 1 TB of RAM, and we can add one more instances as like that, so that on the total it will be seeing as the 2 TB of a RAM and the 2 GB of a hard disk. This is what we need to do is for the horizontal scaling. And when the load is decreasing, we can just remove one instances and we can be able to continue our operation. This is an optimistic way in terms of maintenance and in terms of also the budget wise. And that's why we need to go for the horizontal scaling for the enterprise level. Still, some of the applications are running on the vertical scaling, that is the small scale application. But on the enterprise level, 100% people are using the horizontal scaling. So finally, what it says is scale out via the process model. So we need to scale out as the process is increasing. We need to use the horizontal scaling method. So now we are moving on with the ninth factor, that is the disposability. What is this disposability? See, when we are not, when we don't want to require something, we need to dispose it immediately. We need to dispose it immediately. And when we want to deploy it fast, let's say when you want to do the deployment, when you want to start in a particular service or application, that should get started in a microseconds. It should not take a minute or a hour or the days to get started. So it should not have any dependencies. So when an application is starting, it should connect to the database, it should connect to the Redis cache, it should connect to the Kafka. Yes, we have this all those dependency, but all those startup process should get it done in a microseconds or in a very few seconds. In such a way, we need to architect our application. It should start in such a way, that is, have the less we need to have the less oriented memory startup services, and then restart. When we want to do the restart also, it should go down immediately and it should start up immediately. In such a way, we need to architect our application. See, even when we are doing the DR activities in an enterprise level, when we are doing the DR activity, we will be shutting down the services in one site and we will be bringing it up. If the shutting down is taking 1 hour, and bringing the services up for another 1 hour, it is a great delay. Because we will be having the timeline bounded within us, so that should not happen. That delay should not happen for bringing down, bringing up. So everything should be done at the faster speed. And also the scaling. So when the application we want to scale up, and that also we should do it immediately. That is, when the traffic is increasing, it should provision the another instances immediately, so that the end user will not face any slowness in the application. This is called as the disposability, where we need to maintain all these methodologies. And finally, it says maximize robustness of your services with a fast setup and do the graceful shutdown. Graceful shutdown in the sense, whatever the data, whatever the request which is being processed, and that should not get affected, that should get completed, and then it should go for the shutdown. So we are done with the ninth factor. Now moving on to the 10th factor, that is prod parity, development production parity. So when we are developing the applications, the development environment, it will have, let's say, example, it's having an Oracle database version 11.2, and UAT will be having the another version 12.3. Now, this is a problem which some of the developers will do it. So when we are maintaining a different versions in the different environment, and it won't work in the production as expected. So this is the process which we should not follow, because the developer will say my code is working in development. I don't bother whether it is working in the UAT or in the production. So people will just blame others and they will not take the ownership. And to avoid this, what we need to do is we need to have a same versions or the tools which we are using to develop the product across all the environment. So we should make sure we are maintaining the same versions across all the environment, and this is what is advisable. And in the 12 factor app, what happens is, so we are doing the deployment in the hard time. So once the code is ready in the but once the code is ready in the development environment, which we can promote it to the UAT, and again once it is tested in UAT, we can immediately deploy it in the production. So that's what in the previous factor which we conveyed is. So the process should be fair enough to get started as fast as possible. Whereas in the traditional app, it will take a week. Now, even I could remember like 4 years or 5 years back, people will do the deployment only on the weekends or Saturday, Sunday, or Friday. But nowadays, even on the weekdays, if we have started developing on Monday night, the production deployment is happening. So that is the deployment time has become faster. And the important thing is, the person whoever deploying the code, they are able to deploy it, because how they are able to deploy it in the GitHub. Once they commit the code, it will automatically trigger in the Jenkins and it will get deployed. So we don't want any different people to deploy it in the traditional way. We will have separate team as like a production support team or application support team, where they will deploy it, and they will check the application status. But in the recent times or in the current situation, the developer can deploy the code in the production, and they can check the logs and they can do their sanity. So that's what is happening now. And finally, what we say is keep the deployment, staging, production versions as similar as possible. Okay, to make a faster deployments. Okay, we are done with the 10th one. We are moving on to the 11th factor, that is logs. How logs management is done? See, log management is very important one. Now, once to monitor all the transaction, what is happening in the application, what is happening in the service, what is happening in the server. To monitor all those, this log management play a vital role. Now, for an example, when we have different microservices running, we should not store the logs within the microservices, where the log should be separated from the microservices platform which is running, and the log should be stored in a separate storage server. And that should be propagated to the elastic search as an example to store it. And also it should be processed via the log stack. What is this process? See, once the log got consolidated, it will be processing as a JSON or an XML or whatever the event which it required. And finally we can able to visualize using the another tool, the Kibana, for monitoring it. So that's how this logs management needs to be done, for collecting the logs and storing it in a particular place and processing it and then visualizing it. See, ELK, Elastic Log Stack Kibana, is one of a log management tool which is available in the market. And apart from this, we are also having Splunk, Prometheus, Grafana, Fluentd, App Dynamics. We do have multiple this monitoring tool available in the market. Based on everyone's business case, we can select the respective tool. Okay, so finally what it says, treat logs as a event stream. So the logs will be collected as a event stream and it will be processed accordingly. So we are done with the 11th one, and we are coming on to the 12th one. That is the last factor of this 12 factor app. That is the admin. That is the admin process. See, when we are having an application, for sure, this application will be running behind from the multiple services. When we have multiple services, see, when we want to do some hospitality work for a particular services, we should not encourage any manual changes, or we should not give access to developers or any to log in into that particular server to do some hospitality work, like checking the CPU usages, or checking any transactions, or taking any report, or writing a particular cron job for each and every services. So we should have a separate admin processes to monitor those. So that is, it should be loosely coupled. If you want, we can have the admin process, or if you want to, if you don't want, and we can just remove it. So this kind of an admin processes we should maintain as a separate, that is the loosely coupled processes, and where we can pull the report by using any API calls, and using that report we can able to get the status of the each and every services. See, whatever the maintenance work which we need to do it, that should be separated from the actual business processes. So that's what here we are conveying here. And if we are making the manual process or the maintenance work within the actual service, and that will be considered as the anti-pattern, and which is not recommended in the 12 factor app methodology. And finally, what it says, run admin and the management task as one of the separate processes. So that's it, guys. I'm done with my 12 factors app. If you have any questions, you can ask me. Okay, I hope I have completed in the timeline.
Yeah, okay, Arun. Yeah, thanks for the great session, guys. If you have any questions, yeah, feel free to share it in the chat.
Okay, even in the future, you can contact me through my LinkedIn page. If you want to have a further discussion or any project collaboration, so happy to join with you people. Okay, and thanks for the opportunity, Madurai CNCF team.
Yeah, thanks, Arun. Thanks.
Yeah.